Astronomers do it all the time, and back in late 2019, they spotted something that got everyone talking, a comet named 3IATLAS. At first, it was just another faint smudge, but then it started getting brighter and brighter and brighter. People got excited. Could this be the comet of the century? But just as quickly as it appeared, it fizzled out, breaking into dozens of pieces. The official story is that its icy core, the nucleus, just spun itself apart. But what if there's another explanation? What if 3I Atlas wasn't a comet at all? What if ... it was a spaceship? Let's dive into this fascinating idea. Imagine an alien probe, ancient and vast, traveling through the cosmos for millions of years. Its mission: to observe, to study, to find signs of life. As it approaches a new star system, our star system, it needs to slow down from its incredible interstellar speed. How would it do that? It could use a technique called aerobraking, dipping into the star's upper atmosphere to use friction as a brake. But for a craft this big, that's incredibly risky. A much more elegant solution would be to use the star's own energy. Picture this. The ship unfurls a massive, lightweight structure, a solar sail hundreds of kilometers wide, designed to catch the solar wind and radiation pressure from our sun. As it gets closer, this pressure acts like a giant brake, slowing the craft down from its breakneck pace. To an observer on Earth, this giant, reflective sail would catch the sunlight and get intensely bright, looking exactly like a comet's coma, growing larger and more brilliant. This perfectly matches the initial observations of ATLAS, which brightened 4,000 times faster than a normal comet would. Astronomers were baffled, but the solar sail theory fits like a glove. So the ship has slowed down. It's now in a stable orbit, ready to begin its primary mission. What's next? It needs to deploy its survey equipment. Think about it. A single giant ship can only be in one place at a time. To effectively study an entire system with multiple planets, it would need to send out smaller probes. So, the mothership initiates a deployment sequence. It doesn't explode violently. It fragments deliberately. It releases dozens, maybe even hundreds, of smaller, independent drones. Each one is equipped with its own propulsion, sensors, and communication systems. From our telescopes, this controlled separation would look exactly like a comet nucleus, breaking apart into multiple fragments. We saw Atlas split into at least 30 pieces. Coincidence? Or a perfectly executed deployment strategy? These smaller probes would then begin their journey to their assigned targets. Some might head towards Earth, others to Mars, some to the gas giants or the asteroid belt. They'd be much smaller and stealthier than the main craft, designed to observe without being easily detected. Perhaps they're searching for biological signatures, analyzing atmospheric compositions, or even looking for technological signals from any developing civilization they find. They wouldn't need to be big and flashy anymore. Their goal would be to blend in, gathering data quietly from a safe distance. This explains why the fragments of Atlas seemed to fade away. They weren't just lumps of ice melting. They were individual probes activating their own stealth systems and maneuvering away on their own trajectories, becoming too faint for our telescopes to track. Now, let's consider the origin of this hypothetical craft. The designation 3I means it's the third interstellar object we've ever detected. The first was Oumuamua and the second was Borisov. Oumuamua in particular raised a lot of eyebrows. It was long, thin, and tumbling end over end, and it accelerated away from the sun in a way we couldn't fully explain with natural causes. Some scientists, like Harvard's Avi Loeb, have seriously proposed it could be an alien artifact. What if Oumuamua and Atlas are related? What if they are two different types of probes from the same civilization? Oumuamua could have been a scout, a flyby probe that did a quick reconnaissance of our system. Atlas, on the other hand, was the follow-up, a deployable mission designed for a much more in-depth, long-term study after the scout confirmed our system was interesting. Think of it like a cosmic one-two punch. First, you send a fast, agile scout to quickly check things out. If it finds something promising, a planet in the habitable zone, for instance, you then dispatch a larger, more complex mothership. This ship is designed not just to look, but to settle in and deploy a network of sensors for a comprehensive survey. It's a logical, efficient strategy for exploring the galaxy. The different behaviors of Oumuamua and Atlas suddenly make perfect sense if you see them as parts of a coordinated, intelligent exploration program. They aren't just random rocks. They're tools with different purposes. So, what could these probes be looking for? Life, of course. But what kind of life? Maybe they aren't interested in us specifically. Maybe their mission is to catalogue all forms of life, from the simplest microbes on a moon of Jupiter to the complex ecosystems in our oceans. Or perhaps their purpose is more geological. They could be mapping planetary resources, charting asteroid fields for future mining, or studying stellar evolution up close. The possibilities are endless. The craft could be completely autonomous, a robotic explorer running a program set in motion eons ago by a civilization that may no longer even exist. It's a lonely, silent watchman dutifully carrying out its ancient orders. This idea also cleverly explains the disappearing act of Atlas. A comet made of ice and rock would leave a trail of debris and dust that would hang around for a while. We would see it. But the fragments of Atlas faded remarkably quickly and cleanly. If they were probes powering down their reflective sails and engaging propulsion to move to different orbital planes, they would simply vanish from our sight. They wouldn't be gone, just relocated and cloaked. They could be out there right now, silently orbiting among the asteroids, hidden in plain sight, watching us. It's a chilling, yet awe-inspiring thought. The official scientific explanation that a fragile, fluffy comet spun itself apart is the most likely one based on what we know. It's the simplest answer. But science is all about asking what if. The story of 3I Atlas as a spaceship isn't just a cool sci-fi plot. It's a thought experiment that pushes the boundaries of what we consider possible. It forces us to look at the data from a different angle and to consider that anomalies in the cosmos might not always have a natural explanation. The universe is vast and full of wonders we can't yet imagine. For all we know, we might have already had visitors, and we just mistook their ship for a simple piece of ice. The next time a strange comet appears in the sky, getting brighter and then mysteriously falling apart, maybe we should look a little closer. Maybe we're not just watching a celestial snowball melt. Maybe we're witnessing the arrival. Thanks so much for exploring this incredible what-if scenario with me today. If you enjoyed this journey into the unknown, please hit that like button and subscribe for more deep dives into the mysteries of our universe. And I'd love to hear your thoughts in the comments below. Comet or spaceship? Let me know what you think. See you in the next video.